Okay, so polynomials and sinusoidals will be the very last section of your diploma before the written response. Okay? There's not very many questions on polynomials and sinusoidals. There's only going to be a couple on each, with probably more sinusoidals than polynomials. Okay? You finding what you need? Yeah. I ended up copying the same thing. I didn't mean to. Yeah. Okay. So it says Math 30 students are learning about polynomial functions. The class is currently investigating the number of x-intercepts associated with a function of degree 3. So degree 3 means, yeah, your function has to have an x cubed in it. Okay, and that can be the highest powered x. Okay. Following 4 conjectures were made. So these functions will always have 3 x-intercepts. They will always have 1. They will have 1, 2, or 3. They will have 0, 1, 2, or 3. So this is where you have to know that chart. Essentially, cubics can look like that. So they can have 3. They can look like this, where they only have 2. Or they can look like this, where they only have 1. Okay. They can also look like this. They can have one of those like points of inflection. Remember those wiggles? That also is 1. It's impossible for them to have 0. So they can have either 1, 2, or 3 x-intercepts. So who is true? Brian. And I don't know why, but every time I see the word Brian, I want to say brain. Oh, brain, yeah. And I literally, I'm an adult. I know it's Brian, but I will call you Brain every single time. Like it's just, hey, Brain. Yeah. Okay. So again, this is stuff that's on that chart. Okay. So what I'm betting your diploma question will be on this is something, you know how I said they want to be able to kill lots of things, like with one single question. So they will probably talk about, let's say, a cubic function, and they'll probably give you a bunch of statements. Like it will have 2 x-intercepts, it will have a domain of all the reals, it will have 3 turning points, it will have, and they'll have a list, and you'll have to pick out all the true ones. And so by covering all that terminology in one question, they can literally cover half the polynomials unit in just one question. So the polynomial unit only had 2 concepts. It had all the terminology stuff, like leading coefficient, y-intercept, all that. It had all of that. And the only other thing it had in it was regression. Okay, so you're probably going to get somewhere between 2 or 3 regression questions on the diploma. Okay, so one of them will probably either an exponential reg or a ln reg. The other one will be polynomial and then or sinusoidal. And then the last one, and when I say polynomial, it could be a linear, a quadratic, or a cubic. It could be any of them. So, kicks a soccer ball into the air. Okay, so just think about this for half a second. So time, this is always your X or your list 1. This is your Y and your list 2. So if you're kicking a soccer ball, what should be the path of that soccer ball? Like if you drew it in your hat, it's going to go like this, right? It's going to go up and it's going to come down. That is a quad reg. So this question, it does tell you that it models a quadratic function, but it doesn't have to tell you that on the diploma. So if you're not told what type of regression, you need to plot the points and think about and look at what that shape is. And honestly, for the life of me, I can't remember if on the diploma you were told what regression to use or if you had to figure it out. I don't remember. So when you're doing this, X min, X max, Y min, Y max, right? So you want to make sure that when you plot your points, you're plotting it in an appropriate window setting. So let's just work through the button pushing. So I'm going to need somebody to just shout them out to me because I don't have it on paper in front of me. So clear your lists. So alpha, nope, I already screwed up. Second plus sign, number 4, hit enter. There we go. Okay. Now, hit stat, pick number 1. Okay, so start in list 1. List 1 is where your X's go. Oh, actually, I do have it. No, I don't have it. Okay, can someone tell me what the X's are? Starts at 0. I know that. Okay. Okay. And then for list 2, okay. So make sure that you finish on the same line, okay? And do a quick once over to make sure that it does match because the equation that you find will be based off of the table values, okay? So before I hit graph or do anything, I'm going to go to my window and I'm going to go from 0 to, what was my biggest X? 2. So I'll go to 0 to 5. And then for Y's, my biggest Y was 5, right? So I'm going to go to 10. No idea. Okay. So once you've done your window settings, the next thing you do is go to Y equals, clear out anything that is there, and then you must turn on the plot 1. Remember, you only have plot 1 highlighted when you're doing regression. If you're just doing a plain old Y equals and you're not doing any type of regression, you have to make sure that that plot 1 is turned off. Okay. So I'm going to hit graph and it should plot my points. And you can clearly see it goes up and comes down. So next step now is to find the equation. So stat, over to calc, and you're going to pick number 5 for quad reg. So your choices are for this course, your choices are 4. So 4 is if the points are aligned. 5 is if it's a quadratic. 6 if it's a cubic. Don't ever pick 7 or 8. So 7 and 8 you're never going to pick. 9 is for the log regression. And 0 is for the exponential regression. And C is for the sin regression. Okay, so your choices are 4, 5, 6, 8, 9, 0, and C. Those are your choices. So quad reg, hit enter to activate it, and there you have the equation. So we're going to put that equation into our Y1. So normally it's nasty decimals, right? So we're going to go to Y equals, twinkle, twinkle, little star. Vars 5 over, enter. Ooh. Okay, well, whatever. I don't know why it did that, but I don't care. Hit graph. There we go. So I haven't even answered the question yet. That's just to get me to the answer. So the question is, if the data models a quadratic, the time when the height first hits 3.63 meters. So this is the height. So we're talking about a height being 3.63, and we're looking for the time. So what this is a Y value, and we are looking for an X value. So the way you handle this is on your calculator, you make Y2 that 3.63. Was it 3.63? Okay. And what's going to happen is your graph will have that straight line drawn across. Now the question says the first time it hits. So that means you're looking for this one right here. You're looking for the first time it hits that amount. So you're just going to activate intersect. So second trace number 5. Where's my cursor right now? Where's my cursor? Oh, there it is. It was off the screen. So I just got to move my cursor closer to my point. So you just want to make sure that this cursor is closer to this point than it is to that point. If the cursor is closer to this, that's the one it will find. Okay? Hit enter 3 times. So there it is. Now, it says nearest hundredth of a second. So what does that round to the nearest hundredth? 0.48. Yes. Okay, so make sure that you know how to round. Because if you wrote in 0.5 or 0.47, you're going to get 0 out of 1 just because you didn't do the rounding right. Those are absolutely tragic mistakes, and there's nothing I can do to help you on them. Okay? So just to review polynomials, make sure that you're going through that cheat sheet and you know all the properties of all the functions. At least know what the words mean so that you can find them. And then know how to do regression. Okay? Okay, sinusoidals. So use the graph to answer the next 2 questions. So it says the function above can be represented by a, b, t, c plus d. Find the value of b. So we're looking for this guy. So what you need to know that b equals 2 pi over period. You need to know that. Okay? So period is the length of one cycle. So here's your x-axis right here. Now, does it matter which part of the wave you use as long as you use one complete cycle? No, you can use any part that you want. So I'm just going to go from peak to peak. So I'm going to make my wave that. And the reason why I'm picking that is because it starts and finishes on an exact number. So my wave starts at 4 and finishes at, is that 16? I think so. So from 4 to, is it 14? It's got to be 14. Oh, yeah, it's going up by ones. Sorry, I can't read the picture, so it's 14. Sorry. So it's 4 to 14. So how long is my period? So period is 10, right? From peak to peak. Okay. Now, look at choice A. The answer for A is the period. Period is not B, but we need to find the period to find B. So B is 2 pi divided by 10. So on your calculator, just simplify that down to 1/5. Stick the pi back in. So the answer is D. This is a guaranteed question. They're going to give you something regarding B and period. They're either going to have you find the period and therefore have to find B, or they're going to give you B and you have to find the period. One of the two. Okay, but it's a guaranteed question. Okay? Now, on your formula sheet gives this to you. So that's what's on your formula sheet. You need to understand that you can swap these around, and that's what you need to know. Okay? So depending on what you're looking for, you're going to use that formula either in its given form or swapped around. Okay? What's the value of A? So I'm just going to do it on the other page here. So A, remember, is the amplitude. Amplitude is half the total height. So this thing goes up to 2 and down to -4. So what's the total distance here? 6, right? 6 divided by 2 is 3. So the amplitude is 3. Now, if I go 3 down and 3 up, notice I land right here. And I know this is not part of the test, but this number, see how I landed on -1? -1 is what we call the midline. So the amplitude is 3, the midline is -1. Okay, so you got to keep those two things straight. 3. Yep, so A would be 3. Remember, it's from that midline, it's the distance up or the distance down. So I could have drawn the midline in and found it that way, or I could use this formula here to find it. It's entirely up to you how you want to do it. Usually I find it like this, and then I draw it in just to make sure it matches. I kind of use them as a check and balance sort of thing. Okay. Okay, that's sinusoidal. So the other thing we did was sin reg. So sin reg is choice C, but you do them the exact same way as polynomial reg. So you do your list 1, list 2. You look for this for your x min and x max. You look for this to the y min and y max. And you get the equation. Like that. So that's what the equation looks like. So you'll be given a value for A, for B, for C, and for D. But it's all done the exact same way that we just did the last quad reg. But again, window settings are key. When we reset your calculator will be in radian mode. That's all you need. Don't ever change it out of that. Leave it in radian mode for the entire diploma. Okay. Okay. You knew it was coming. I left it till the end. Okay. This is the very first unit we started with. Okay. The reason why I started with this unit, yes, it is the hardest unit of the course. We started with it because I needed to give my 30, if anyone was in 30-1, I need to give them a chance. So last semester, I had 30-1 and 30-2 in the same semester. It gave 30-1s a chance to come into 30-2 like a week or so in. And since the 20-1s have seen this entire unit, for 30-1 kid to come in, it wouldn't matter because they've already seen it all, right? So that's kind of why I did it that way. I am going to teach things a little different next year. I'm not going to do the entire rationals unit at the start of the course. I'm only going to do the multiplying and dividing, and then I'll save the add, subtract, and equation solving till the end, just because that was the tricky stuff. That was the nasty. And for some of you, that just blew you out of the water. Okay? So make sure you go and look at those cheat sheets. The cheat sheets have all the rules on them. Okay? So we're just going to go through this step by step, and I'll add in little notes here and there as well as long as we go. The key with rationals, the first step that you're going to do every single time is you're going to check to see if you can factor. So remember, factor is trinomials, it's greatest common factor, and it's difference of squares. So you're going to check to see if you can factor every single time. Okay? So multiplying and dividing are substantially easier than adding and subtracting. So we did 4 concepts in this unit. We did multiplying rationals, dividing rationals, adding and subtracting rationals. We did solving rational equations, and we did restrictions. So NPVs, I think we called them. So those 5 concepts are what's crucial to this. So NPVs is what this one is testing. So what NPVs are, it doesn't matter if you're add, subtract, or times. So for add, subtract, or times, the NPVs, where your eyes go, is the denominators. And what you're doing is you're trying to figure out what x cannot equal because you can't have the denominators equal to 0. For dividing, When you do the restrictions for dividing, you have to still look at the two bottoms, but you also have to look at the second numerator as well. The reason for that is when we learned how to divide rationals, what was the first thing you did after factoring? You changed divide to a times, and then what did you do with the second fraction? You flipped it. So now the top became the bottom and the bottom became the top. So because this will eventually land itself on the bottom, that's why we have to give its restriction. Okay, so this question is on the easier side because it's a multiply. If they give you a divide, it's a little bit of a harder question because you have to remember to look here as well. It's also an easier question because they factored everything. There's nothing to factor here. So all you have to do for this question is look at the two denominators and ask yourself, what can x not equal? Well, what take away from 3 would give 0? Right, because positive 3 and positive 2, because 3 minus 3 would give 0, 2 minus 2 would give 0. So answer is B. Now, look at choices C and D and A. So choice A, the i's went right here. Choice C, their i's went here, here, and here. Choice D, they did all 4. So reason why I bring that up is that on the exam, they're not going to have one choice with a 3 and a 2, another one with a 4 and a 5, something with a 7 and a 9. They're all going to have 2s and 3s and positives and negatives, but they're all going to have 2s and 3s in them. So they're not going to make this easy on you. Okay? Pardon me? Now, I can't remember for the life of me, now that I've told you that polynomials and sines are the last thing you see before written response, I'm thinking maybe this unit's the last thing you see. I can't remember. It's towards the end. I know it goes puzzles, set theory, perms, comms, probability. Then it goes exponents and logs. And then the last two, I'm not sure. If it's polynomial sine rationals or rationals and poly sine. One of the two. And then written response after that. Okay, so when simplified, the quotient. So again, they have done the factoring for us. So the factoring has been done. So we don't have to factor anything because they have already done that. So the first thing we do when you have a divide question is you change divide to a times and you flip the second fraction. So instead of writing it as x minus 5 squared, I'm going to write it as x minus 5, x minus 5. My reason for that is we're trying to get brackets to cancel off. So anytime I have multiples of a bracket, I always write it out so I know exactly how many brackets I'm clearing off. So when you cancel off brackets, you can cancel brackets vertically, or you can cancel brackets diagonally. Okay? You can only cancel on multiplying questions. You cannot cancel on adding and subtracting. Okay? So this x minus 5 cancels off with only one of those x minus 5s. In order to cancel off the other x minus 5, I need another x minus 5. Can I cancel off the x plus 3s? Nope, because they are horizontal. Okay, so the final answer is x minus 5 on top, x plus 3 on the bottom. So the answer has to be A. Now look, the first time we did rationals, it sucked. A lot of you did not like it. We've had a whole semester of mathing. Your brain is smarter. You can handle numbers better. You can handle hard things better. So hopefully when we come through this now, it'll be like, huh, that actually isn't bad. It shouldn't be. Okay? Okay, adding and subtracting is not your friend. I cannot emphasize this enough. Adding and subtracting sucks. It does. It just sucks. Okay? So, first thing you're going to try is you're going to try to see if you can factor. Okay? Oh, hang on. Hold on. Let's go back here. What would the restrictions be for this question? At what point do you do the restrictions? You do them at the beginning. Okay? So you want to do the restrictions. So you want to do the restrictions before you cancel everything off. So you still have this. You still have this. You still have this. Okay? Which ends up being the same as the other. So it's plus 5, negative 3, plus 5, negative 3. So it's just that. Okay? But you want to do restrictions before you cancel off any brackets. Okay? Okay, so for adding, subtracting. First thing we do is we check to see if we can factor. Oh, this is not a nice question. Okay, and then the second thing you're going to do is you're going to find a common denominator. Third thing you're going to do is you're going to change your numerators. And the fourth thing you're going to do is you're going to simplify. There is no shortcutting this. It's just nasty, plain and simple. Common denom. It's not demon, it's denom. Okay. That's okay. Okay, so 2x minus 12, let's start with that guy. What can I do with 2x minus 12? I can take out a 2. What am I left with after I take out a 2? X minus 6. So if you're not sure if you've done common factoring right, in class, what we did was this. I said, hey, if you're not sure if you've taken out the 2 right, go back and multiply it back. So 2 times x, 2 times 6, you end up right back where you started, so then you know you did it right. Okay, so here's what makes this question absolutely horrible. Do you see this 6 minus x? And do you see this x minus 6? They are opposites. So what we want to do is we want to rewrite the 6 minus x as negative 1 times x minus 6. So you want to flip it around and take it to essentially you're taking a negative 1 out of it. Okay? So that now you have the same binomial bracket. Okay, so when you see opposites, pick one of them to flip and stick a negative 1 in front of it. Look, if I multiplied it back, negative 1 times x is negative x. Negative 1 times negative 6 is positive 6. So this and this are saying the same thing. I'm just writing it so that I now have the brackets looking the same. So now what we do, so that's step 1. Okay, step 2 is common denominator. So what we need to do for step 2 is you multiply the numbers. So we need a negative 2. And then we need the bracket. Now you only need one of them. You need one of every different bracket. Okay, so if I have 3 x minus 6's, I still only need 1 x minus 6 in my denominator. Okay, I'm going to keep going. I'll give you your break. Okay, so here's my numerator. Okay, so I'll just use a different colored pen. What did I multiply negative 1 by to get out negative 2? 2. So since I multiplied the bottom by 2, I have to multiply the top by 2. Now, does the bottom already have an x minus 6? Yes. So the top Doesn't need another. So this has an x minus 6, this has an x minus 6, so I don't need to add in an x minus 6. Minus 1. Okay, so 2 times by what will take me to negative 2? Negative 1. This has the x minus 6, this has the x minus 6, so I don't need any x minus 6's. So 3 times 2 is 6. So we have 6 minus negative 1. So we have 7 over negative 2, x minus 6. So if I look back up my choices, okay, so here's what the diploma did. Just like hope, negatives float. Okay? Hope floats, negatives float. If you have a negative on the bottom, float it to the top. So negative 7 to x minus 6. So there's your answer. Okay. One last thing. I know it didn't ask for it. What's the restriction? Nope. Look down to right here. So what take away 6 minus what? 6. What minus 6? So they're both 6. So I don't use the 12 one, Kaylee, because I use the factored version. That's why you always want to use the factored version. Okay. Do I include 2? No, because it doesn't have an x, right? Okay, take your break. We'll pause here. So like I said, nothing overly pleasant in that. Here's the thing. It's going to be 2 questions on the diploma. You're going to have probably 1 add subtract question, which will be horrible. And you're going to have 1 solving equation. So on the January diploma, the solving equation question was in the written response. That is good because you get credit for your work, but it is bad because it's not worth 1 mark, it's worth 2 or 3. But you get credit for the work. So it's not 0 out of 1, it's maybe 1.5 out of 3 or 2 out of 3 or like whatever it is. So with solving equations, they're almost identical to add subtract. Okay. First thing we're going to do is check to see if we can factor. Second thing we're going to do is common denominator it. Third thing we're going to do is change the numerators. So again, this is exactly the same as add subtract. Fourth step, and this is where it can take a left turn or a right turn. If you have just x's and numbers, you're just going to solve it like you are in grade 8. So if you're just left with x's and numbers, you're just going to solve it. If you have x squareds, x's, and numbers, you have to make it equal 0. And then you're going to either factor it or use quadratic formula. The quadratic formula was the diploma exam. It was the worst possible scenario possible. Now we spent an entire 90-minute block just solving with quadratic formula. I slowed right down. I took an extra day in that unit to do that. So if you go back into the Google Classroom or you go back into your notes, you will see a lesson on solving rationals with quadratic formula. Okay. And unfortunately, that was the long answer question. So it was absolutely worst case scenario. I gasped when I figured it out. Thank you. Because Hughes had told me time and time again, oh, yes, it's in the curriculum that they have no quadratic formula, but they always make sure it's factorable. They always make sure it can be factored, so don't worry about it. So I didn't teach it in my first semester, and it was on the diploma. So none of those. So my 20-1 kids did fine because they had seen quadratic formula from grade 11 and used it. And yes, 20-2 kids see quadratic formula, but not in this context. And so none of my 20-2s going into 30-2 got it right. And even my 20-1s went, whoa, like this is nasty. So they second guessed that they were doing it right because we never practiced it in class. So I made a point of stopping for an entire day and doing it with you. Now, whether or not you remember that from February, probably not, but we're going to review it. Okay. Okay. So other thing to note, 1 mark. Just because it's worth 1 mark doesn't mean it's 1 step. So the amount of work you do is not in line with the amount of marks it's worth. Okay? Okay, so x squared minus 9, this is a difference of squares. So it's x times x. 9 is 3 times 3. You make 1 a plus, and you make 1 a minus. Remember difference of squares? Okay, so we're going to cross that out. Okay, so common denominator, you now have to do both sides of the equation. So I'm going to do the numbers first. Do I have any numbers in the bottom? Just numbers. 5. So I need a 5. And then I need one of every different bracket. So I need an x minus 3. And I need an x plus 3. So that is step 1 and step 2. I factored and I found a common denominator. Step 3 is to now change the numerators. So this one starts with a 1. So this denominator, hold on, let me just change my mode here. So this denominator has the x minus 3. That's it. So that means I need to times the 1 here by the 5 and the x plus 3, because that's what it's missing. Then I have this minus 6. So this denominator has the x plus 3 and the x minus 3. So what is it missing? Just the 5. The last numerator has the 1. Okay, it's got the 5. That's it. So it needs the x minus 3 and the x plus 3. Okay, look up here. When you're adding and subtracting, once you've changed the numerator, you keep the denominator. Like this, you just keep rewriting it out all the way along, right? When you add, subtract, you just keep writing that denominator out. You don't do anything with it. You just keep rewriting it out until you're done simplifying down the top. With solving equations, right here, you're going to have an extra step where you're going to cross out all of the denominators. So you're going to go swoop, swoop, and now we just go in and solve. So 1 times 5 is 5. 5 times x, 5 times 3. Minus 6 times 5 is 30. So I'm just going 5 times x plus 3, and then 6 times 5. Now for here, does multiplying by 1 have any effect? No. Do you already know what x minus 3 times x plus 3 equals? What does x minus 3 times x plus 3 already equal? X squared minus 9, right? You already know that this is that. So I'm going to write in x squared minus 9. Okay, so do I have just x's and numbers left? Or do I have x squareds, x's, and numbers left? I have x squareds, x's, and numbers. So I'm on this column. Okay. So what you want to do is you want to make sure that the x squared stays as a positive number. So right now I have a 1x squared, which is positive. If it happened to be negative, you want to move everything to the other side. If it is positive, you move everything to the side that it is on, because you have to make it equal 0. So I'm going to move all of this over, so I have 0 left over here. Now, just as an intermediate step, 15 minus 30 is negative 15. So now I'm going to move all of this over. So the x squared, I'm not moving. This is a plus 5x on this side. So how do I move a plus 5x? What is it going to be on the other side? Right, minus 5x. What is this negative 15 going to be on the other side? So that is 6. Okay, this is factorable. This is tic-tac-toe land. So we put the x squared in the middle. We write the negative 5x off to the side. And we put the plus 6 in the bottom right. And we're going to leave that diagonal alone. Okay. What times what will give you x squared? Okay. What times what is 6? Right, it's either 2 and 3 or 6 and 1, right? So I'm going to do it wrong just to show you what it looks like, and then I'll do it right, okay? So the wrong choice would be 6 and 1. So don't write this down, just look. So 1 times x is 1x. 6 times x is 6x. Well, we know that 1 plus 6 is 7. We're trying to get out negative 5. And you're going to be like, okay, well, I can do that. I can make this guy negative, right? But is x times x squared? What is 1 times negative 6? Negative 6. I have to end up with a positive 6. So it did not check out. So what I have to do is change my line of thinking, and I have to try the 2 times 3. So what's 3 times x? What is 2 times x? Now, right now, 3 plus 2 is 5. I need negative 5. So they both have to be negative. Now, let's check again. X times x, great. Is negative 3 times negative 2 now positive 6? So we've got here 0, x minus 3, x minus 2. So what does x equal? What minus 3 is 0? What minus 2 is 0? 2. Okay, last piece of this, and this is your 5th step. You must check your x not equals. So all the way back to right here. What are my restrictions? Do I include 5 in the restriction? No. X minus 3. So what's that restriction? X plus 3. What's that restriction? Okay, so those are my restrictions. So my restrictions are positive 3 and negative 3. Okay. I'm hoping you're seeing the problem here. So here I'm saying x equals 3, but here I'm saying, nuh-uh, x cannot equal 3. Those two things contradict each other. So when I get this solution, but that's also a restriction, I have to cross that off. Do you remember what it's called? It starts with the letter E. You get a donut if you can name it, whether you want one or not. Extraneous root. Extraneous. Okay? You get a donut. Okay? So an extraneous solution is a solution that you found, but it conflicted against the restriction. So the only answer is x equals 2. That is horrible. Yeah, all that work for 2, for 1 mark. Now, okay, that's the other thing here, guys. That is 1 mark. And as my new t-shirt says, slow down. You've got 6 hours. Okay? It's my birthday this weekend. Okay? So again, now I think this is why on the diploma they put one of these in the written response. Okay? Because it's way too much to deal with. Okay? But yeah, sorry, not sorry. Okay? The point is that we go through it. Look, at the end of the day, it's going to be 1 mark, maybe 2. Okay? So if this is the only thing that you are struggling in the entire course, it's going to stop you from getting 100, but you'll still get a 95. Think of it like that. Okay? Couldn't tell you. I think there's 8. Oh, this is just, no, these are diploma style questions, but a teacher had pulled a bunch from different exams together, and so she ended up with more than what you actually have. That's why the numbers mean nothing on here, okay? Okay,